Instant skill acquisition, or ISA, represents the theoretical leap from traditional, laborious learning to rapid, tech assisted mastery. While traditional mastery requires thousands of hours of study, ISA aims to compress this timeframe by directly influencing our neural pathways. By 2026, we have transitioned into the era of assisted skill transfer. This is not science fiction, but a convergence of BCI and generative AI. ISA technology directly facilitates the mastery process, allowing us to acquire complex skills in a fraction of the time currently required. Modern brain-computer interfaces, or BCIs, act as a bridge between neural activity and external feedback. These closed-loop systems continuously monitor neural firing patterns. By tracking action potentials in real time, the interface decodes the brain's unique signals. This precision allows the system to identify the precise moment of intent. The interface provides immediate neurofeedback, which stimulates synaptic potentiation. This strengthens existing connections, effectively bypassing inefficient pathways. By guiding the brain toward these ideal states, we can accelerate procedural memory formation, turning months of struggle into days of efficient mastery. Neuroplasticity is the fundamental biological process that allows our brain to adapt and reorganize. By using specialized neurostimulation, we can now prime the brain, locking it into a state of hyperplasticity. At the microscopic level, this priming optimizes synaptic transmission. By facilitating the release of neurotransmitters, we lower the activation energy required to forge new, durable neural pathways. This process allows individuals to compress thousands of hours of standard practice into weeks of primed learning, effectively bypassing the natural, slower biological learning curve. Generative neurofeedback creates a precise biofeedback loop between your neural activity and AI-driven training modules. AI models generate a digital twin curriculum, mapping your brain's unique structure to find your optimal learning mode. By identifying mental friction, the AI adjusts inputs to bypass inefficient synaptic pathways, accelerating cognitive growth. Skill compression redefines mastery. Traditionally, achieving expert status in a field like surgery or diplomacy takes roughly 10,000 hours of practice, most of which is spent navigating redundant information. By utilizing AI to strip away noise, we identify the minimal viable knowledge. This process compresses 10,000 hours of redundant theory into 500 hours of high-impact focus. This acceleration enables the rapid deployment of specialized skills in high-stakes environments. Whether it is performing complex microsurgery or navigating intricate diplomatic negotiations, experts are now ready in a fraction of the time. Real-world applications are already yielding results. Project Aegis utilized BCI-assisted haptic feedback to train surgical residents. In clinical settings, neurofeedback helps map cognitive strengths to optimize how professionals absorb new, complex data. Diplomats are now achieving conversational fluency in rare languages in under 100 hours of training. These tools represent the beginning of a shift in how humans achieve professional excellence. The rise of instant skill acquisition creates a growing cognitive divide. A permanent split risks emerging between those who can afford neural augmentation and those who rely on natural learning. We also face the risk of atrophy of cognitive grit. By bypassing the struggle of traditional learning, we may lose our critical thinking and the resilience built through hard work. Societies must now debate if this technology is a public utility accessible to all or a luxury private asset that dictates one's social status. The path forward requires balancing innovation with equity, ensuring that the quest for mastery does not cost us our human agency. The future of skill acquisition isn't just about faster data downloads. It is about fostering adaptive expertise, the ability to think critically in novel situations where AI might fail. By 2030, McKinsey reports that over 35% of the workforce will rely on neural enhancement tools for their daily professional tasks. The ultimate challenge is balancing this technological speed with human judgment. We must avoid cognitive atrophy and preserve our ability to analyze information critically. Ultimately, success will depend on those who leverage neural tools while keeping their cognitive grit sharp. The future belongs to the adaptive thinker.